Good day, this is Ryanel, and today we will learn how to build a sine wave model using MATLAB Simulink. If you are a newbie in modeling and has background in C programming, then this tutorial is suitable for you as it gives overview of how to create a simple sine wave model using Simulink tool. In this material, you will be introduced to Simulink and will know what Simulink is and how to use this tool. The know-how in using Simulink is divided into 5 sections. Getting started with Simulink, Simulink Library Browser, Block Libraries, Toolboxes, and building a model respectively. By definition, Simulink is an environment for simulation and model-based design for dynamic and embedded systems. Simulink offers interactive graphical environment, customizable set of block libraries, quick way to develop your model, integrated solvers, and design, simulation, implementation, and testing of time-varying systems. Ergo, Simulink is a software package for modeling, simulating, and analyzing dynamic systems. It supports linear and nonlinear systems, modeled in continuous time, sample time, or a hybrid of the two. Systems can also be multi-rate. This means that different parts can be sampled or updated at different rates. For modeling, Simulink provides a graphical user interface or GUI. For building models as block diagrams using click and drag mouse operations, it can build models in a hierarchical fashion using both top-down and bottom-up design approaches. Now that we know what Simulink is, the next step is to understand how to use it. Open the MATLAB application in your desktop. You can open Simulink by clicking on the Simulink icon on toolbar or typing Simulink on MATLAB command window. Click Blank Model to open Simulink Workspace window. This workspace allows the user to build models using blocks stored in Library Browser. The Simulink Library Browser is the library where you find all the blocks you may use in Simulink. To open the library browser, click View in the menu bar and select Library Browser. The block set for model construction relative to its library is being shown. You can select a specific block by typing it on the search window. Simulink software includes an extensive library of functions commonly used in modeling a system. These include continuous and discrete dynamic blocks such as integration, transfer functions, transport delay, etc. Math blocks such as sum, product, add, etc. Sources such as ramp, random generator, step, and so forth. Here are some commonly used continuous blocks. Integrator, used for continuous time integration of the input signal. State space model. Transfer function. Transport delay that applies to specify delay to the input signal. And PID controller. Here are some commonly used math operations blocks. Add block, gain, multiply or divide inputs, and sum block. Here are some commonly used signal routing blocks. Multiplexer, demultiplexer, receives signals from the go-to block with a specified tag, sends signals to from blocks that have the specified tag, switch, and manual switch. Here are some commonly used sinks blocks. Display, output port, terminator, to workspace, XY graph, floating scope, and scope. Here are some commonly used sources blocks: step, signal generator, ramp, random number, and signal builder. In addition, we also have the following commonly used sources blocks: input port, constant, pulse generator, and repeating sequence. The description of the block is revealed when you hover the mouse to it or simply right-clicking the block and selecting block parameters. You can also see detailed explanation and examples of the block by right-clicking it and selecting Help. In addition, there are lots of blocks in different toolboxes. You can simply click and drag them by selecting the desired toolset in which the block or blocks are stored. Below are the available toolsets in our LDP for MATLAB R2017A version. You can see available toolsets in your PC by simply typing ver, which means version, in MATLAB command window. Now that we are already familiar with different blocks that can be used in Simulink, we can now proceed to create a simple model in Simulink. In the menu bar, select File, New, and click Blank Model. The workspace where you can construct your model appears. This is where you can build Simulink block diagram. Simulink block diagram is the pictorial model of a dynamic system. Each block represents an elementary dynamic system that produces an output, either continuous or discrete output. The lines represent connections of block inputs to block outputs. There are lots of parameters you may want to configure regarding your simulation. Select Model Configuration Parameters in the Simulation menu. The following window appears. Here, you set important parameters such as start and stop time for the simulation, what kind of solver to be used, example, ODE 45, ODE 23, etc. Fixed step or variable step. Note, each of the controls and the configuration parameters dialog box corresponds to a configuration parameter that you can set via sim and simset commands. Solvers are numerical integration algorithms that compute the system dynamics over time using information contained in the model. Let's proceed to building a model. The following steps will guide you to construct a system model. Step 1. Creating blocks. Step 2. Making connections. Step 3. Set parameters. And Step 4. Running simulation. Step 1. Creating blocks. In Simulink Library Browser, click the Sources library. Click, then drag and drop the sine wave block to Workspace window. This is the sine wave block dragged from the Sources library. Save this model by clicking the Save icon in the Workspace window and specify the desired file name and directory. Select Gain Block from the Math Operations library and place it on the Workspace window. Do the same thing for MOOCs block from Signal Routing library. Lastly, drag to Workspace and Scope blocks from Sinks library. Since we need two Workspace block, you can simply right-click and drag the first to workspace block. Step 2. Making connections. To make connection, left-click while holding down Ctrl key on the keyboard and drag from source port to a destination port. This is now the connected model of sine wave. You can specify the name of the model by clicking and dragging annotation in Explorer bar. Now that the blocks are connected, you can specify the parameter values. Step 3. Set parameters. Double-click the gain block to set the parameter for the gain block. Put a gain value of 5 and click Apply and OK buttons. Name the output parameters of two workspace blocks as Out1 and Out2 respectively. Save and run the model. Step 4. Running simulation. Click Model Configuration Parameters to set up the desired parameters. You can change the stop time and then click the Apply and OK buttons. In this example, we will use the default setting of the configuration parameters. In the Workspace window, click the Run button to run the simulation. After running the simulation, you can view the results by double-clicking the scope block to display output of the scope. Note, scope block is similar to oscilloscope. You can select the scale X and Y axis limits to fit the graph to frame. The yellow line is the input sine wave, while the blue line is the output of sine wave with a gain of 5. You can also change its properties by clicking View in Scope's block toolbar, selecting either Configuration Properties or Style. Lastly, the outputs of the two workspace blocks Out1 and Out2 are reflected in base workspace. Simply click the variable to see the output in matrix form. You can also plot the output using plot function. Simply type below command in MATLAB command window and press Enter key. Now, you just created a simple sine wave model in Simulink. In a nutshell, you learned the following. What is Simulink? How to use Simulink? What are the commonly used blocks in library browser? Configuring simulation using configuration parameters? Creating and simulating sine wave model in Simulink, viewing results using scope block, viewing variables in base workspace, and plotting output using plot function. You are now ready to crank up Simulink model in retrospect of your desired project. Thank you very much.